Here is worksheets from chapter 5. And this part, this table is given. On the first column, we have response: never, rarely, sometimes, most of the time, always. And on the right side, we have frequency for each one of these. Part 8 is asking to find probability. In this part, we say probability, and that is same as relative frequency. So how we can find probability is same as relative frequency. First, you have to find sum of all frequencies. We'll add all these numbers. That is equal to 4,663. And then finding relative frequency, we have to use, for never we have 102. Use that frequency divided by sum of all frequencies. And here it's asking to run to nearest 1,000. So running that is 0.022. Next one, for rarely, we have frequency is 321. So same thing, divided by sum of all frequencies. Run, that is 0.069. Sometimes is 517 divided by sum. Here is 0.111. Most of the time, frequency divided by sum. Running, it's 0.227. Next one, for always, frequency divided by sum of all frequencies. Running, it's 0.572. Now part B, would you consider it unusual to find a college student who never wears a seatbelt? So here we have never, and the answer for probability for this part was 0.022. It's asking is probability of never. Is that one less than 5%? So when we're trying to see if and even it's unusual, we have to compare that with 5%. If it was less than 5%, that means it's unusual. So the answer for this part, if this one is unusual, is yes, because this probability is less than 5%. Now here on this part, we have 52 cards. Part A, it's asking to find probability of randomly selected queen or 3. So total we have 52 cards. We have or. We should add. So here we have these two events, queen, and the other one is 3. How many queens we have? It's 4. So out of 52 cards, we have 4 queens, and out of 52 cards, we have 4 cards that are 3. And there is nothing in common between these two. And here it's asking to run to 3 decimal place. So the answer is 0.154. Part B, probability of queen or 3 or king. Here again, there is no intersection between all these 3 events. There is nothing in common. For each one of these, we have 4 cards. So 4 queens. Plus, here we have or, so we're adding. Here we have 4 cards that are 3 divided by 52, plus we have 4 cards that are king, again divided by 52, That is equal to 12 over 52, rounding 0.231. Part C, probability of 2 or diamond. We have a card that is diamond and also it is 2. So at the same time, we have both of these events on one card. That means there is a card in common between these two. So in that case, we should subtract. So first, we have to count how many cards we have that are 2. It's 4 cards. Plus how many diamonds? It's 13 cards. So this is what we have. It's 52 cards. We had this part in lecture. Here we have 4 groups. Diamonds. This is one of the events that we have in part C. And how many diamonds we have? It's 13 cards here. How many 2? We have 4 cards. Counting these cards, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 cards. And then count how many 2? It's 1, 2, 3, 4. We counted this card twice. That's why we should subtract. We cannot repeat. We cannot recount the card. So here we should subtract that one card. So subtracting the card that we recounted. Add all these on top, we have 16 divided by 52, rounding 0.308. Now here on this part, we're going to work based on this data set. We have Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and we have total columns. We have male, female, total. Part 8 asking to find probability of male. Here we have table total. That is 39,591. And then we should have what we have for male total is 25,854. So use that number divided by table total and then round to 3 decimal places. So 25,854 divided by 39,591, rounded to 3 decimal place, that is 0.653. Part B, probability of Wednesday. When we're trying to find these, probability of our denominator will not change. Our denominator is always table total, so same number, but numerator change based on what event is given. So on this part we have Wednesday, and we have for male, female, and if total was not given, we should add these two to find this one. So total what we have for Wednesday is 5,010. Use that number divided by table total. 5010 divided by 39,591 rounding, it's 0.127. Part C, probability of Wednesday and male. So here we have and. So Wednesday and male, we have to see what is in common between these two. So this is Wednesday. This is male. The part that is in common is this part. And the number that we have here is 3,315. So using that number, 3,315, what we had in common between two events divided by table total. 39,591 rounding to 3 decimal place. The answer is 0.084. Part D, probability of Wednesday or male. This is not same as part C. Here instead of and we have or. So this part is equal to probability of Wednesday plus probability of male minus probability of Wednesday and male. We have the answers for these from part A, B, and C. So using these three, I can find the answer for part D. So probability of Wednesday is part B. We can use these decimals, but it's better to use fractions because it's asking to run to 3 decimal place. And when it's asking to run to decimal places, that means that you should run the final answer. So I'm not going to run these three here, but having all these fractions first, add, subtract, and then finally run the final answer. So I'm only running the final answer. Here we have 5,010 divided by total plus for male divided by total minus what we had in common divided by total. So the denominator will not change, it is same. So here we have adding, subtracting what we have on top in the numerator. We have 27,549 divided by what we have in denominator. Now running your final answer to 3 decimal place. It's 0.696. So that's the answer for this part. Part E, would it be unusual having these two events, Thursday and female? So finding the answer for this part, probability of Thursday and female. Here we have and. We should see what we have in common between these two events. So this is Thursday. Here is female. So what we have in common between these two events is this part. We have 1,818, this number, divided by table total is the answer for probability of Thursday and female. So running to 3 decimal place. Here again, it's asking for 3 decimal places. The answer is 0.046. So it's asking if this is unusual. We have to compare with 5%. So see if this number is less than 5%. Yes. That means it's unusual. So in this part we have it would be unusual because the probability is 0.046. And that is less than 5%. So you can write this is low or it's less than 5%. It's better to write this one because this is the rule that we use. But in your homework, you may have this part given as multiple choice. You may have low or high. So in that case, choose this one, low. So if less than 5% was not given, use that one for multiple choices. Grocery bag can be classified as either paper or plastic. Suppose that 97% of grocery bags are classified as plastic. So what is given here on the spot, probability of plastic, that is equal to 97%. Part A, 2 grocery bags are chosen at random. What is probability that both grocery bags are plastic? So here we have to find probability of plastic and plastic. Or we can write probability of both plastic. So that is equal to probability of plastic is 97%. We have to multiply this number by itself 2 times because of having 2 grocery bags. Or use power. So 97% to the second power. And the answer is 0.9409. So the answer for this part is 0.9409. Part B, it is same as part A, but here we have 4 grocery bags. What is probability that all 4 are plastic? So this is probability of plastic and plastic and plastic and plastic. It's 4 times. And instead we can write probability of all 4 plastic. That means we have to multiply probability of plastic by itself 4 times, or instead use power. So 0.97 power is 4. And the answer is 0.8853. Part C, what is probability that at least one of 4 grocery bags is paper. So probability of at least one paper that is equal to 1 minus. I cannot have none of these paper because it says at least one should be paper. So this means I have to subtract this part, probability of non-paper, from 1. Or in other words, that means 1 minus probability of non-paper means all 4. So we have 4 grocery bags. So non-paper is the same as all 4 plastic. So we should subtract this part from 1. It's 1 minus. We had the answer for this part in part B, 0.8853. And the answer is 0.1147. So the probability is 0.1147. And then it's asking, would it be unusual that at least 1 of 4 is paper? So here again, when it's asking for unusual, we should compare with 5%. And if that number was less than 5%, that means it's unusual. If it's not unusual. So in this case, this number is not less than 5%. That means it's not unusual. Now here on this part, we have these 2 data sets, male, female. Part A, what is probability that randomly selected driver Fidelity, who was female, was 35 to 54 years old. So who was female was 35 to 54 years old. On this part, the event that is given is this one, so that is given. It says that driver is female, and it's asking if that driver is in this age group 35 to 54 years old. So here is our question. The finding probability, first writing with our question is 35 to 54. Given that driver is female, so that is equal to probability of 35 to 54 and female divided by probability of female. So this is equal to, so this part I use probability. That means we have to find probability for each one and then divide, simplify. But if we had number of, we could find the number that we have in common between these 2 events and divided by what we have total for female. So the answer will be same. So probability of 35 to 54 and female, what we have in common here is this number, 4,773. So use that number divided by table total is 54,649. Now denominator we have to find probability of female. Add all these numbers to find total for this column is equal to this number. Divided by table total. So 15,013 divided by 54,649. Now finding the answer, use this number on top, multiply by what we have here in denominator. So multiplying these two numbers, what we have here on top, multiply by 54,649. Then denominator we have to multiply these two numbers. So we have 54,649 multiplied by 15,013. We can simplify. $4,773 divided by 15,013. So this part cancels. And here is what we have. The answer is 0.318. So we are using what we had in denominator for each one of these probabilities. Probability of 35 to 54 and female. The denominator was 54,649, and that was same for probability of female. We had same denominator, 54,649, but here we cancel that number. What that means, we could use this number, 4,773, in numerator divided by what we had in denominator for female total. But in that case, you have mathematically, if you want to write that, here we have to use n number of elements instead of p for probability. So the answer here is 0.318. Part B, what is probability that a randomly selected driver who was 35 to 54 was female? So given is 35 to 54 and female. That part is question. So it's asking if this driver is female. On this part we had for these two, part A and B, we had given first and then question after. But sometimes you may have question first and then given. So probability of female given 35 to 54, that is equal to probability of female and 35 to 54. So that is same as what we did in part A. And then divided by what is given, it's probability of 35 to 54. So here we have to add these two numbers to find sum for 35 to 54. And that is 17,154. 56 divided by total, table total. So simplify, here we have to divide these two numbers. Rounding. The answer is 0.278. Part C is a victim of a fatal accident aged 35 to 54, more likely to be male or female. So we have the answer for if that driver is female, that was, the probability was 0.278, but we should also find what is the answer for if the driver was male. We can do the same thing and find the answer for male. So here we have probability of male and 35 to 54 divided by probability of 35 to 54. So what we have in common between male and 35 to 54 is this number. $12,383 divided by table total over probability of 35 to 54. Simplify. Rounding. The answer is 0.722. So find the answer this way, or probability of male given 35 to 54, that is equal to 1 minus probability of female given 35 to 54. So 1 minus what we had for probability of female given 35 to 54, that was 0.278. So the answer here is 0.722. Now compare what we had here on this part with this one. So comparing female, male, here we have multiple choice. The one that is correct is this one. The driver is more likely to be male because the probability of male is greater than what we have for female. Because the probability, but here it says because the probability is greater than 50%. So the answer is part D.